The first type of symmetry that you're going to learn about is called reflection. For example, if you look at each of these pictures, the idea to reflection is if I were to draw a line, the two halves will match up exactly. So like for letter A, do you see where the line goes? Right there. Roughly, the pieces on both sides match up. Okay, take a look at letter B. Find all the places that you would draw the line. Okay, some of you see it. It's the same idea as the first one, right down the center. I mean, it should always be down the center when you think about it. Okay, so if you look, both halves match up. There is another line that we could draw. Good. Down the center. The opposite direction. Yep. If you look, the pieces on each side, the top and the bottom, will match up. Okay, so this is what you're going to do. Copy this down. We are going to do this for coordinate points. Our line of reflection is the x-axis, and we're going to locate where these points are. Got it? How about now? Now? Ready now? Tell you what, pause the video. As soon as you're ready, press play, and then we'll start reflecting each of these points. Okay, you should be done. Here's what you're going to do. You should have a piece of grid paper. You're going to draw an x-axis and a y-axis. So, draw an x-axis. Yeah, that's the axis going horizontally. We're going to draw a y-axis going up and down. Right there. Okay, the positive numbers go to the right. Now put the numbers right on the line. 2, 3, 4, 5, 6, 7. Negatives go to the left. Positives go up. Again, you put the numbers on the lines, not the spaces. Negatives go down. Okay, now, the first coordinate point, according to our table, is 1, 2. So, looking at the table, we're going to plot the point 1, 2. So, at 1 on the x-axis, I go up 2, place a dot. Okay, now, we are going to reflect this point across the x-axis. It's going to be on the opposite side, and if we were to fold along the x-axis, the 2 points will match up exactly. If you reflect it correctly, it should be right here. Yeah? If I fold along the x-axis, the 2 points would match up. So let's see. If I'm going to fill in the table, the reflection is going to be located at 1, -2. Is that okay? You need to find the reflections of the other 2 points. Okay, press pause. Try and figure it out. The next point is at 3, 4. Okay, so I put a dot. Look for 3 in the x-axis. I go up 4, place a dot. Now, I need to reflect it across the x-axis. So if I were to fold the paper along the x-axis, the points should match up. And you should have gotten right there. Yeah? So, in which case, for I to fill in the table, you should have got 3, -4. I think some of you are starting to notice something when you reflect across the x-axis. If I do the next one, 5 comma 6 is right here. If I reflect it across the x-axis, it's going to be on the other side, right here. Five comma negative 6. Okay, now the long way is to actually plot the points out, but hopefully you'll see that something's happening. If I reflect across the x-axis, something happens to the coordinate point. Got it? Let's try this again. Copy this down. Ready? Okay. We are going to plot the points. It's the same points as the last time, but this time the line of reflection is the y-axis. We're going to reflect it to the other side of the y-axis. Okay, so the first point, again, is at 1 comma 2. So if I were to plot the point, 1 comma 2 is right here. This time we're going to reflect it across the y-axis. So if I were to fold along the y-axis, which is up and down right here, it's going to be on the other side. The reflection would be right here. In which case, if we were to fill in the table, if I reflect across the y-axis, the reflection should be at negative 1 comma 2. If I reflect 3 comma 4 to the other side of the y-axis, it would be right here. In which case, you should have got negative 3 comma 4. Hopefully you're seeing it again. Something's happening with the coordinate point. One more time. At 5, 6, I reflect it to the other side of the y-axis. Yeah, so if I were to fold along the y-axis, right there would be my coordinate point. That would be the reflection. So, if I reflect 5 comma 6, the reflection would be at negative 5 comma 6. Okay, there's one more line of reflection that you need to be concerned about. Copy this down. Got it? The y equals x line. Now, when I say the y equals x line, that means the y and x coordinates will be the same. So, let's think about this. 1, 1, that's where x and y are the same. 2, 2, yeah? The x coordinate and the y coordinate are the same. 3, 3, 4, 4. Okay, so if you look at this, if I connect every single one of these points, that is going to be my line of reflection. So, right, that's my line of reflection. I'm going to use this to reflect across. Okay, so the first point is at 1 comma 2 again, right there. If I reflect to the other side of the line, now this is going to seem weird, but if you just tilt your head and look at it, it has to be on the other side. Some of you are going to put it over here. That's not it. It's on the other side of the line. So if you look at it right there, this right here would be the reflection. The coordinate point that you would fill in would be 2 comma 1. Already some of you might be guessing what the rule is for this when you reflect across the line. Let's just prove it works. Okay, so let's do it again. At 3 comma 4 is right here. It reflects to the other side. If you notice, from here all the way across to here, yeah, if I fold, they're going to match up. And the coordinate point would be 4 comma 3. At 5, 6, 5, go up to 6. You see it? It's on the opposite side. If I fold it, that's the reflection right there. 6, 5. Okay. Again, you should see something happening with the coordinate points when you reflect across the y equals x line. Let's try. Going back to the x-axis. If I said the coordinate point was x, y, if I reflect it across the x-axis, do we have a rule? Okay, let's see. All the x coordinates stayed the same. All the y coordinates, they switch. So y becomes -1. Well, not necessarily negative, but opposite. Whatever y is, it changes its sign. If I reflect across the y-axis, if the coordinate point was x, y again, whatever x is, it changes its sign. So since x is 1, it becomes -1. X is 3, -3. So this would be sign change. The y value stayed the same. If I reflect across the y equals x line, the coordinate point is x, y. Hopefully you see this rule. Good. It's y, x. No sign changes. They just switch place. And that's it. You're reflecting across each of those 3 lines.